So in this question, this is a graph. This is a question of graph where as far from land as possible. So what we have to do? There are given n cross n grid containing value 0 and 1, where 0 represent water and 1 represent land. So we have to find a distance, a maximum distance, the nearest cell, which is maximized. It means we have to find the maximum distance from the 0. Like I am explaining the question, so understand easily at this stage. So we take a grid, we take a simple grid like this, like 1 0 0 1 0 0 0 0 1 1 1 0 0 1. Okay, so this is a land and this is a water. So what we have to find it, we have to find a minimum step to reach at land. So what I'm saying to you, we have to find a minimum step to reach a land. Well, that means we have to find the minimum step to reach a land, and we have to find the step, how many steps we take, how many steps, like this, like this. This is one step to add, one step add. This will take one step to reach a land, and this take two steps to reach a land. This take two steps to reach a land. Okay, and also this land also take one step and one step to reach a land. So we have to find this two. We have to find the maximum of minimum step. It means it takes two minimum. It takes only two minimum step, and this will take only one minimum step, and this take 0 1 minimum step. So we have to find the maximum of these minimum steps. So this will take two minimum steps to reach this land. So we have to find the minimum and the maximum of these minimum steps. Okay, so you understand what I'm saying to you? So this is our land. Okay, so what I'm doing here is, so this is your land and this is your water. Okay, so in this question we have to just find the maximum of the minimum step. Okay, so it takes one step and it takes two steps. So this is our answer. Okay, so what is approach we have to do? We have to apply a BFS, simple BFS. When we apply a simple BFS to 0, then it will move with the radius d. Like it will come here 1, it will go here, it will go here, it will go here. So it will add his one step, add his one step. Okay, and then it will move here, it will add his one step neighbors, and then it will reach here, and it will again, and this node will add his neighbors, and this will got 1. Okay, this will got 1, and this will added his one step, but this will added his one step. Okay, so from 0, the distance from this 0, like from one step, from 0, from the one step forward from this 0 is 1, and from this 0, the next step, the next value is 0 here. Okay, so it takes one step, so this will take one step. Okay, and when we apply BFS at this stage, then this will consider one step. Okay, so it will give a one step. Okay, so it will take one step to reach land. Okay, and this also will take one step to reach 1, because when we apply BFS at this stage, it will find our land. Okay, so it will contain answer as a 1. Okay, so and also this 0, but this 0 will, when we move radiusly, but it in the first step it will not, sorry, there are many I think there are many type of rough step here, so we're just explaining clearly so you understand easily. So what I'm saying to you is, initially this 0 will move. Initially this 0, when you apply with BFS at this stage, then it will contain a 1. Okay, so it will contain a 1 in the first row, so it will take a one step. Okay, so it will answer as a 1. Okay, and then when we apply BFS here, then it will also contain a 1. Okay, then it will also contain a 1, so it will take a one step to reach a land. But this 0 not contain any land in initial stage, so it will take one step, and also it will take another step, then it will take two steps to reach a land. Okay, so So this is your basic approach. This is your basic approach to apply a VFS at every node, at every zero. So we apply VFS at every zero. When we apply VFS 0, then it will contain this 0, then it will contain this 0, okay. And when we apply VFS 0, then it will contain this step. So it will take a one land. But when we apply VFS here, then it will this 0, then it will move a first, when it takes one step, then it can't find any land. When it takes second step, then it will find the land. So it will take two steps. So we had 2 and we had 2, and when this 0 will take a one step and it find lands, okay. So this is answer 1. And when we apply VFS here, then it will take one step to find a land, okay. So this is 1, and this 0 also will take one step, so this is also 1, okay. So then we find the maximum of these ones, so this is our answer is a 2, okay. So this 2 will answer, okay. When we apply a VFS here, then it will find land is 1, okay. So this is a single VFS, and when we apply VFS here, then it will find answer is 1 step, because when we apply VFS here, then we find that our land is 1, okay, here 1, okay. But when we apply VFS here, in the first VFS it can't find the land, okay, but in the second VFS it find land. But here G0 will find in first VFS it find the land, okay. So this will take a one step, and also this will take one step, because in the first VFS it finds the land, okay. VFS moves with radiously, so it will move here, it will move here, it will move here, it finds a 1, so it will take a one step. But this will, when this step will move radiously, then it will find this 0, this 0, this 0, this 0, this 0, but it can't find this one, okay. So it will again move to here, it will again take a step, and it will again, then it will find the land. So it takes 2 steps. Now I think you have to clear about what I'm saying to you. So we have to go to dry run so that you understand what I'm going to say, okay. Like this one, this is 0, this is 0, this is 1, okay. This is 0, this is 0, this is 0, this is 0, okay. This is 1, this is 1, this is 1, sorry, this is 0, this is 0, this is 1, okay. So now what I'm saying to you, like we have to just add a queue, just take a queue. Sorry, this is our, so the approach which I'm telling to you, this approach is like it takes a more complexity, because we reach at every node and we apply VFS, and here also we apply VFS, and it takes one step, and it takes one step, but this will take 2 steps, this will take 2 steps, it takes 1 step, it also take 1 step, it also take 1 step, and we find the maximum of these, and then the 2 step is our answer, okay. So we reach at every node and we reach at every node and find our land, our nearest land. But where our complexity is very high, because we reach at every node, and apply a BFS, okay. So we can apply another approach, which is like this approach. So the approach is something this. The approach is like, this is our 1, this is our 0, this is our 0, this is our 1, and when this is our 1, when we apply a BFS at this stage, then we reverse the all order, because what I'm saying to you, if we apply BFS 0, then it will search the all condition. Like if we get 1, then we stop here, and then we will tell you that we take a 1 step to find out the distance, okay. But when we apply BFS from here, when we apply BFS from our lands, then we can find out that how many levels, how many distance from the water. It find that how many waters are presented from my position. How many distance is calculated from my position, like from the one, how many water land is possible. Like from 1, this will take 1 step, and also this will take 1 step. So this will this place is a 1 step far away from that position, but this position will take 2 steps. This position is a far away from 2 steps, okay. So what I'm saying to you is that we apply a BFS from, so we apply a BFS from 1. Okay, so when we apply a BFS from 1, then it will move, radiusly, and also it will move radiusly, and also it will move radiusly, and also it will move radiusly, and make these all ones. Okay, what I'm saying to you, you understand by this example. So we take a queue, simple queue, we take a simple queue and add its land, add its land. Okay, so the position is 0, 0, 2, 0, 1, 2, and 0, 1, 2, 3. Okay, so this is our 0, 0 position, and we initially add 0, 0, and 2, 0, and 3, 0, 3, and 2, 3. Okay, sorry, this 2, 3, this 0, 0, and this 0, 3. Okay, so initially this is our level 1, this is our level 0, this is level 0. Okay, initially this is our land. Okay, this is our land, but then we apply a BFS at this here, then it will add this, then it will add this and this. Okay, it remove and it will add, whatever position, 0, 1, and make as a 1 step. Okay, make as a 1 step. Okay, so this is 0, 1, and 1, 0. Okay, from 1 we just go to reach 1, 0, and 0, 1, sorry, 0, 1. Okay, so it will remove, and then also 2, 0 will remove, 2, 0. When the 2, 0 will remove like this, then it will add our neighbors like this, and it will also already added, so it will not add it again. Okay, so 2, 0 will add 2, 1. Okay, 2, 1. Okay, then this 0, 3, this 0, 3 will remove, this 0, 3 will remove, and add this and add this. Okay, and make is wasted. So 2, 1 will be added, 2, 2, and 1, 3. Okay, when this will added, and it will make 1. Okay, and then again 2, 3 will sorry 0, oh sorry, I'm giving a wrong answer. The wrong answer is this, that. Okay, yes. So when the 0, 3 will remove, then it will add this position and this position. Okay, so when 0, 3 will remove, then it will add 0, 2, and 1, 0. Okay, this will add this neighbors now. So then when so 0, 3 will remove, and then 2, 3 will remove, and then when 2, 3 will remove, then it will already added now, so it will not again added. So this will add only 2, 2. Okay, so this will add only 2, 2. Okay, so this level, so this and this and this level will finished. So after level 0, we added one distance far away, our water. So we add a water which is far away from land as a 1 distance. Okay, 1 step. So this is our 0 step, and these all take 1 step to reach at land. Okay, because we added 1 step, like we added 1 step, far away, we added the all waters which is 1 step far away from our land. Okay, so these all waters is take 1 step to reach this land. Okay, so we reach, we add all that positions. Okay, so now when we add again, when we going to add again from that position, when we again apply a BFS from that position, so what we are getting is from 0, 1, like this 0, 1 in the sense, at this position, when we apply a BFS at this position, then what we get 1, 1. Okay, because this will add it again and this will add it again, so we get only one position, which is 1, 1. Okay, this will remove. Okay, and same when we reach at this stage, like where 1, 0, 1, 0 is like where we were here, 1, 0 is like this. Okay, so this will remove again, and it will again add only one step, which is 1, 1. 1, is already added, so it will not add it because this will already added. It makes 2 step. because this is our one step and this will our two step. Okay, because this is our one step now, 0 to 1, and this is your second step. This is your second step. Okay, because this will remove and move to next step. When we apply BFS, then this is your next step now. 0 comma will again apply BFS, and it will move again take a one step. So for that, from that level, this is a 2-second step. Okay, from that we take one step, and from that we take one step. From level 0, this is your second step. Okay, from that position, this is your second step. Okay, so this is your second step, and 0 comma 0 will add 2. 0 comma 0 will going to add 1 comma 1, but it already added, so it will not add again. Okay, so 2 comma 1 will remove, 1 comma 0 will remove, and it will go to 2 comma 1. Okay, 2 comma 1 is this, 2 comma 1, 2 comma 1 is this. Okay, and also going to add this, but it is added again. Okay, so it not again, so it not again, it can't be added again. Okay, so sorry, this will not add again anywhere, so it will remove, and when we are going to reach at 0 comma 2. 0 comma 2 is this. Okay, and also it can't be added again because all things are added, but here this will add it again, and the position is 1 comma 2. When 0 comma 2 will remove, then it will add it. When 0 comma 2 will remove, then it will add this neighbor. Okay, and this will take a one step again. So this is our second step. This is our second step nodes. This is our second step nodes, and all these nodes. Okay, these nodes. Okay, so we create again so that you can understand what I'm saying to you. This 0 1 0 1 0 0 0 0 1 0 0 1. So we take this position. When we apply a BFS, then we reach here, then we take one step, then we again apply BFS, then we find this one and this step. For this step we take two steps. Okay, we take 2 steps to reach here. Okay, so this will our answer, 2 steps. For this also again, when we apply BFS, then it will take, one distance, and then he take one second distance. Okay, so then it will get 2 step. Okay, so everywhere we take a 2 step at this step. Okay, so we are going to code it so that you can understand what I'm saying to you. Okay, so now what I have to do, we have to take a linked list of pair class. Okay, what class? Pair class. And then we take a queue. Equal to new linked list, and then we just take a for int I equal to 0 and I less than grid 0 dot length. Sorry, there are we put grid dot length I plus plus, and we'll take for int j equal to 0 and j less than grid 0 dot length comma j plus plus. Then if grid I j equal to 1, what we have to do, we have to just take a q dot at last. We have to just q dot at last new pair. In the new pair, what we have to add? We have to add I comma j. Okay, so this is a condition where we got our one land. Okay, this is the place where we get our land, and we just add the position of land. Okay, so after that After that we apply a Q. We just check out the Q size, okay? And if our Q size is equal to 0, then it means we doesn't get any land, okay? And also it can be happen that that Q dot 0 dot length multiplied with grid dot length. It means we got at every position one. So this is these two conditions will tell us that we have to just stop here and move forward, and don't move forward, because this is our edge case. If Q dot size equal to 0, it means there are not any land. If Q dot size is equal to grid 0 dot length multiplied grid 0 dot length, it means that everywhere we got 1, okay? When we got everywhere 1, that it means everywhere land is possible. No any water is created, okay? So this is our edge case. Now we have to take a direction array. Why we take a direction array? Because we have to move in all 4 directions. So we have to take a direction array, okay? So we take a direction array. So we take a direction array, okay? So the direction array is like 0, comma minus 1, and then again we take a 0, comma 1, then again we take a 0, comma 1, then we take a 1, comma 0, 1, comma 0, and then we take a 0, comma minus 1, okay? And then we take a minus 1, comma 0, okay? So this is our 4 directions, and then we take a label. Then we take a label. Then we take a label equal to minus 1, okay? This label will tell us that how many steps we are taking to reach the destination, to reach the land, okay? While Q dot size is greater than 1 second, we have to just go here so that we can code it in a good manner, okay? Now Q dot size. The camera is, I think, close, so that I'm confused. Sorry. So Q dot size is if Q dot size is greater than 0, then Q dot size is greater than 0, then we just go in the loop, and then we just increase our level, 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 okay? Increase our level, and then we just find our size, Q dot size, and then we wait that this size will going to be 0, then until if this size will greater than 0, if this size will reduces to 0, then we have to wait until, okay? So after that the size will decrease, then we take a pair of Q dot remove first, okay? And where we take a pair Q dot remove first, okay? Pair are equal to Q dot remove first, okay? Then we take a var int I equal to 0 less than I less than 4, okay? So when we take I less than 4, and then we take I plus plus, okay? So this will take a 4 direction. This will tell that we apply a BFS in all 4 directions. We check, okay? So if row will greater than or equal 0, and then column will greater than or equal to 0, and end. It means row less than grid dot length. Okay, and end. Column less than grid 0 dot length. Okay, and end grid row and column. Okay, grid row and column equal to 1. So at these stage we cannot be moved. Okay, so at these stages we cannot be moved. Okay, sorry, at this stage we can move, because this stage will capable to apply a BFS, because we move at these stages only. Okay, so now when we reach at these stages, then we add q dot add, then we add dot q dot add last q dot add last new pair, q dot add last a new pair. Okay, so q dot add last new pair, whatever pairs, like row and column. Okay, oh sorry, I'm taking a mistake, something mistake is this. I think I'm not remaining. So we have to take a direction now. We have to take a 4 directions now. So I'm not taking their directions. Okay. It's okay. R dot row, R dot, sorry. We take a pair now. We take a pair S. And we take a pair S, and then we take S dot row plus S dot row plus dir I. Then we take 0. Then also we take a column equal to S dot column plus dir I 1. Okay, then what we are going to do, then we have to just add this step. Okay, and then what we are going to do is we have to just make this vested. Okay, then we have to just make this vested, that it will reach at the land. Okay, so it will move, it will tell us that it will reach at the land. Okay, so now after that we return our level. Okay, after that we will return our level. Okay, so this is our code. Okay, so what is our code? Just discuss the code. So in this code we take a q, and then we just check out that if we get a grid I and j equal to 1. Okay, if we get I and j equal to 1, then we add that position. Okay, then we can add that position. Okay, and after that, if we got that our q dot size equal to 0, and our q dot size equal to grid dot length multiplied by grid dot length, then it will tell us that this is our edge case. Okay, this is your edge case, because it will not happen that the q size equal to 0. It means that the all is land. If the q size is 0, sorry, if the q size equal to 0, then all the waters, they are not in land. If the q dot size equal to grid dot length multiplied by grid dot, it means that all the land. Okay, all the zeros, all the land, so no any water is presented. Okay, at here the level plus will represent the levels. Okay, that at which level we are presented. Okay, so if we take a 2 level to reach the water, then it will tell us, then this outer loop will tell us that it will take a 2 step. Okay, so this is your code. So we have to just run it. I think it takes a minute. 1 second. We run again. What is the error? Local open run one. Okay, I think this was line at the error at line number 1. So we got this type of error. Okay. Sorry. So what we are getting error here? Okay. So we just take the position 0. So this is our condition now. We just put a 1. So we can't put the condition 1 because we can't move to land. Okay. So we have to just move to 0. Okay. So we have to just run it and submit it. And then we just go and dry run this question. So submit it. So just go to and something like dry run type things we have to do like this. Okay. So we take our loop like sorry. I think someone was mistakes. Yeah, okay. Now we take a 0, we take 1, we take 0, we take 1, we take 0 0 0 0 0, we take 1 0 0 0 1. Okay. So initially the queue size will added this. So okay, the queue will added these ones. Okay, like this. So like this. Okay. So there are we add a 0 comma 0 and sorry 0 1 2 0 1 2 3, and this the position is that this is the position of 2 comma 0 2 comma 0. This is the position of 2 comma 3. This is the position of 2 comma 3, and this is the position of 0 comma 3. I think 0 comma 3. Okay, 0 comma 3. Okay. So initially we added all the positions. Okay, from tower sync array. So initially we take level plus plus. Okay, we initially take a level -1. So we take initially level 0. So this is our level 0. Okay, we increase the level now initially. So we take a q dot size equal to, we take the q dot size which is equal to 4, Okay, so initially we apply the loop, initially going to all the 4 directions from this. Okay, so when we're going to all the 4 directions, then when the loop will run, that will add these ones. Okay, when we take a 4 direction, it will add these zeros. Okay, so it will add these all labels. Okay, so it will add 0 comma 1, this 0 comma 1, and it will add this 1 comma 0. Okay, like this 1 comma 0, and this 0 comma 1 will add it from this 0, and it will remove from the position, and then 2 comma 0 will remove, and it will 2 comma 0 will remove now, and it will again add it, the loop will again run, and q dot remove first, and then 2 comma 0 will remove, and when 2 comma 0 will remove, then it will add all neighbors like 1 comma 0, which is this, and then add 2 comma 1. Okay, 2 comma 1. Okay, then 2 comma 3 will remove, this 2 comma 3 will remove, and then this 2 comma 3 will remove, again this will loop and 2 comma 3 will remove, and then this 2 comma 3 will remove, this then will added with the 0 comma 2 and 1 comma 3. Okay, this added. Okay, and then at the last 0 comma 3 will remove, when the 0 comma 3 will remove, sorry, 2 comma 3, sorry, my mistake. I think this 2 comma 3 is not running. Okay, sorry, we mistake it. The mistake is when this 2 comma 3 will remove, or when this 2 comma 0 will remove, then it will add 2 comma 1, this 2 comma 1, and also it is going to edit 1 comma 0, but it will already edit, so 2 comma 1, so this 2 comma 0 will not edit this because it already edit 1 comma 0. Okay, so when we are going to that stage 2 comma 3, this is our 2 comma 3 stage. Okay, so when this and we are reached at this stage, when 2 comma 3 will remove, then it will edit 2 comma 2. Okay, this 2 comma 2, this 2 comma 2. Okay, and 1 comma 3, 1 comma 3. Okay, so and then when we remove 2 comma 2 again, when we remove 0 comma 3, this 0 comma 3, then it will add 2 and this state. Okay, so this is the position of 0 comma 2, and and it is going to edit this 1 comma 0, but it is already presented like 1 comma 2, sorry, 1 comma 3, I think, no? 1 comma 3 presented already, so it will not edit again. Okay, so this is our second level. Sorry, this is our first level. Okay, after removing this, we reached here q dot size, and then we just remove this step again. Okay, so q dot remove first, so this is our first step, and then we move here. Okay, and then 0 comma 1, and this 0 comma 1 will remove again, this 0 comma 1 will remove again, because this all will become ones. Okay, when we reach here, all 0 will become ones. Okay, so it will all ones removed will becomes ones, and when we are going to remove, then this one only take this one step, and this one only take this one step. Okay, so after that, when we remove all values, only we get 1 comma 1 at this stage. At a third stage, we get only 1 comma 1 and 1 comma 2. This is our second level when removing all this, because when we're removing all the stuffs, then we get 1 comma 1 comma 2 at the last. Okay, this is our second level. Okay, and we return this level. Okay, and we return this level. Okay, so this is our answer. Okay, so I hope you understand what I'm saying to you. Okay, so thank you for watching this video.